Today is our second day on solving system of equation word problems, and today we're going to take a look at two different types of word problems. One is distance word problems, and the other type of word problems are mixture. So we're going to take a look at distance word problems first. As you know from last year, or the year before, 5th grade even, distance equals rate times time, where d is the distance, r is the speed or the rate, and t is the time. So in the first example, two cars are 700 miles apart. One car is traveling at an average speed of 45 miles per hour, and the other car is traveling at an average speed of 55 miles per hour, and they are traveling toward each other. If they maintain their average speeds, how long will it take them to cover the distance? And what we're looking for is how long will it take them to meet. So I'm going to set this up in a picture first. The cars are 700 miles apart. Car 1 starts over here and is traveling that way at a speed of 45 miles per hour. And car 2 is traveling towards car 1 at a rate of 55 miles per hour. And we want to know how long is it going to take them, how long is it going to take the two cars to meet. So we're also going to set this information up. We're going to organize it in a table. So for car 1, we know that the rate is 45 miles per hour. We don't know what the time is, so we're going to use t for time. So if we use our distance equals rate times time formula, his distance or her distance in car 1 is 45t. Car 2 has a rate of 55 miles per hour. We don't know car 2 times either, but we do know the distance, which is 55t. Because distance equals rate times time. We just know the distance in terms of the time. So we're going to write the systems of equations. We know that the total distance that the two cars traveled, car 1 plus car 2, has to equal the total distance of 700 miles. I don't know cars 1 distance, actual distance that the car traveled, but I do know that car 1 has a distance of 45t, car 2 has a distance of 55t, and that total distance traveled has to be 700 miles. So where did those numbers come from? So again, we'll look up here, car 1, if distance equals rate times time, car 1 traveled a total of 45t. And in car 2, the same thing, distance is rate times time. We don't know the distance the car traveled, so we have to write that distance in terms of time, and that's 55t. We're going to solve the system to find out how long it will take the two cars to cover the 700 miles. So our systems that we wrote, 45t plus 55t equals 700 miles. 100t equals 700, and so t equals 7. So it takes 7 hours for the two cars to meet. The question didn't ask this, but if we want to know how far car 1 and car 2 drove, we know that car 1 is 45t and the time was 7 hours, so car 1 covered a total distance of 315 miles. Car 2's distance was 55t or 55 miles per hour. Car 2 also traveled for 7 hours for a total of 385 miles. And if we add 315 and 385, we get a total distance of 700 miles. Problem 2 is a similar question to problem 1, except for this time the two vehicles, in this case trains, are not traveling toward each other, they are traveling away from one another. So I'm going to draw a picture first this is the train station, and they both leave Penn Station at 8 a.m. The train heading south travels at an average speed of 155 miles per hour. So this we'll call train 1, and it is traveling at 155 miles per hour. Train 2 is traveling in the opposite direction, and train 2 is traveling at 170 miles per hour. The question is asking, when will the distance between the two trains, when will that distance be 2,762.5 miles? So how long is it going to take those trains to be 2,762.5 miles apart? So we're going to do the same thing we did with the other equation. We are going to set it up in a table as well. So for train 1, we know that train 1's speed is 155 miles per hour. We don't know what that time is. That's what we're looking for. But we do know that the distance covered will be 155 miles times however long it takes it. Train 2 is traveling at 170 miles per hour. We don't know the time for that one either, but we know the distance is 170 times however many hours it travels. So we're looking for the total distance between the two trains to be 2,762 miles. So I want to know when the total distance, these two distances, adds up to 2,762.5 miles. And so we've already set up our system. Okay, we know that the distance that train 1 travels plus the distance that train 2 travels has to equal 2,762.5 miles. The distance train 1 travels is 155 t. The distance train 2 travels is 170 t, again for a total distance of 2,762.5 miles. We're going to solve this system. 155 plus 170 is 325 t equals 2,762.5. Divide by 365 and we get a time of 8.5 hours. So it takes 8.5 hours for the two trains to be 2,762.5 miles apart. The second type of problem we're working on is a mixture problem. How many gallons of a 12% salt solution must be combined with a 42% salt solution to obtain 30 gallons of an 18% salt solution? Well, this is where, your head might explode, but that's okay. We'll walk you through this. So we're going to define our variables. We're going to let x equal the number of gallons. And then I'm going to draw a picture down below to hopefully it'll clear it up just a little bit. So if I have, whoops, don't want to do that. I need my pen. So if I have 30 gallons, this whole thing is 30 gallons of an 18% solution. The first part of my problem says 12%, or part of that, which we're going to call x, part of that is a 12% solution, and the remainder, which is 30 minus x, because it was 30 gallons, I'm taking away x, so it's 30 minus x. The remainder of that is at 42% salt solution. So the combination of the 12% and the 42% has to give me 30 gallons at 18%. So how am I going to write that as an equation? So let's go back up here. 12% as a decimal is 0.12. So 0.12 of some number of gallons plus 42% as a decimal is 0.42 of the remainder, which is 30 minus x, is the same as 30 gallons at 18%, which is 30 gallons times 0.18. So I'm going to distribute and combine like terms. 12x 42 minus time 0.42 times 30 minus x is going to give me 12.6 minus 0.42x, and 30 times 0.18 is going to give me 5.4. Combine like terms. 0.12x minus 0.42x is going to give me a negative 0.30x plus 12.6 equals 5.4. Subtract 12.6 from each side. I get 0.30x equals a negative 7.2. Divide by negative 0.30 and I get x equals 24, and that's 24 gallons. So the question is, solve the system to find how many gallons of each solution is needed. So 24 is going to give me the 12% solution, 24 gallons. And then 30 minus 24, 30 minus x, which is 30 minus 24. That's the 6 gallons. And that's the 6 gallons of the 42% solution. So 6 gallons at 42% plus 24 gallons at 12% is going to give me 30 gallons at 18%. Yes, so let's take a look at the picture of this again. Here's my 30 gallons at 18%. I have part of that is 24 gallons, and the other part is 6 gallons for a total of 30 gallons. The 24 gallons has a 12% salt solution, and the 6 gallons has a 42% salt solution. And then these two combined, the 24 at 12% and the 6 at 42%, will give me 30 gallons at 18%. Okay, last problem. Investment problems are a type of mixture problems. You have twice as much money invested at 8% as at 5%. And if your annual interest income from these two investments is $315, how much money is invested at each rate? So how much money do we start with? We don't know. So X is the amount of money invested. So let's look at the first part of this. You have twice as much invested at 8%. So twice as much of what? As much as the amount that you invested. So at 8%, you have twice what you invested at 5%. Well, how much did you invest at 5%? You invested X. So we're going to write those without the percentages. So 8% times 2x is 0.08 times 2x, and 5% x is 0.05 times x. So the total from the first investment, which is this one, and the total from the second investment, which is this one, has to be $315. So 0.08 times 2x plus your other investment, which is 0.05x, has to equal $315. and $15. So we're going to distribute and combine like terms. This gives me 0.16x plus 0.05x equals 315. Combine these two together, and I get 0.21x equals $315. Divide by 21/100, and I get x equals 1,500, and that's $1,500. So I invested $1,500 at 5% interest, and then at 8% I invested 2 times that, so 2 times 1,500. I invested $3,000 at 8%. So if I want to see if these two totals do add up to $315, $1,500 times 5% is $75, and then $3,000 at 8% is $240, and this total right here will give me $315. Now it's your turn to practice multiple choice question number 1. A group of campers and one group leader left a campsite in a canoe. They traveled at an average rate of 10 kilometers per hour. 2 hours later, the other group leader left the campsite in a motorboat. He traveled at an average rate of 22 kilometers per hour. How long had each boat traveled when the motorboat caught up with the canoe? So draw a picture, and this is similar to the walking question that we had a few days ago. I think it was with Ming and Maddie, maybe. You can draw a picture similar to that and then see how long it takes the canoe to catch up to the motorboat. On his way to work. From home, your uncle averaged 20 miles per hour. On his drive home, he averaged 40 miles per hour. If the total travel time was 1.5 hours, how long did it take him to drive to work? Use the following system to help you answer the question and solve for T. So again, please go to the Google form to answer multiple choice question number 1 and free response question number 2.